Welcome to a new test and teardown video. This time we're going to look at another EA power supply. This one is the model 7065-100. So that means it is 0 to 65 volts and 0 to 10 amps linear power supply. I believe this is one of their biggest series, so this is really big and deep and heavy. Oh yeah, let's try and put it on the scale, by the way. It even covers my entire scale. So here you go, more than 20 kilos, yeah. Gonna power this up for you now, okay? So of course this is a linear power supply, but it's also pre-regulated, if I'm not mistaken. I think it is the same kind of topology they're using in all their power supplies. So when I crank this on, I will be zooming in on my amp meter here. So look to your upper right, the amp meter, okay? Are you ready? Can you hear the hum? So we got 42 watts of idle power. Oh, I can even feel the vibrations. There's a very loud hum. When I crank up the output voltage, I'll do that, and then we will see on the amp meter what is going to happen at the same time, okay? Upper right again, and now I crank up the voltage. Did you hear that? Now it's up. And then I crank it down again. Up again, and then down again. So this is how the pre-regulator works. We got some capacitors in here, and it is pre-regulating and charging some capacitors. I can't wait to open this. Maybe I should show you a little clip from the specifications sheet. We got quite a lot of different versions, and this is the highest in volts and amps in this series. Again, we also got different configurations, remote sensor, remote control, and all that kind of stuff as well. And oh yeah, it's important to mention I released another video a few months ago. I will put a link in the description to that previous video. That video reveals some design bugs I found in this power supply about the transformers. They were running really warm, and also the internal regulators, they didn't have a thermal contact to the outer mechanics, so it's running very warm on the inside, but then ice cold on the outside. That was super easy to fix, but please look at that previous video as well. And now I will open this one, and we will see if this one got the same kind of problems. So what do you know? This is exactly the same circuit board as the one that was in the previous video. So that means this video is going to be quite short. I'm not going to repeat the whole design topology, how this one is pre-regulated and how it really works, because the schematic and working methods, that is very deeply detailed, explained in my previous video. So please go there if you want to know how this thing works. Maybe I should just try and explain that the schematic is definitely a nightmare. Complete, utterly nightmare. But the design is very nice. Design idea and all that is really nice and cool. It's just drawn by somebody who don't know how to draw schematics. That's just all there is to say about it. With the same faults in the thermal design is here. So completely repeated. You can see when I'm holding the camera angle here, you can see straight through here. So that means there is no thermal connection between the heatsink and the chassis. And unfortunately, it is also the same in the output power regulator. Look at that. Distance and thermal isolation. So that is the same. This one is the 650 watt model. So that is why it is fully equipped with both of the transformers. And it is end control checked in 1997. And if you already went through my previous video and you have seen the funny design box about the temperature, idle power, and it was mainly in the transformers. The fun thing is, it is exactly the same problem in this power supply. So as you see here, the screws in the transformer create a connection to the metal, so the eddy currents in the iron core is now shorted through this metal stick here. See how hot the metal stick is, and that is because current passes through this metal stick to that other screw. So it's not that bad in this end. The fun thing is that it's the screw and the metal here that creates obviously the short and the problem. So that was in the right transformer. Let's look at the other one. See? Isn't that fascinating? And also there's a huge mechanical noise from the transformers. That's definitely how they are mounted in the metal in the bottom plate here. So they are vibrating and causing this to be amplified throughout this metal bottom case. You can definitely feel the vibrations. The fun thing is the vibrations are clearly, yeah, they are a lot louder on this side. So yes, I will try and see if I can fix it in this power supply as well. So idle power at the moment is 42 watts. I also see some other parts that's creating some loss, of course. That is some of the regulators down here. Ooh, this one is 77 degrees. Really? It looks like it's the connector. Oh dear. This can't be right. Gotta be me who is looking at the camera wrong. It has to be that regulator there, right? But we don't have the fan running. Yes, we do have the fan running. So there's a temperature control that will turn on the fan linear. So that means when it starts. I just needed a little help here to get it started, and I believe that is the regulator that is controlling the fan. So now we'll have a little bit of air going around in here. What else can we see that is getting nice and warm? Yeah, we got a heatsink down there and all that kind of stuff. It's not so interesting. Oh, that hum is just loud. So now I'm done removing all the screws here to the top shorted problem. And my idle power dropped to 36 watts. So it's not a lot of watts, but definitely there is a high current going on here and something is heating up. It also depends a lot on how hot it is, how good a contact there could be to this piece of metal. So I kind of don't like this problem. So I will now add the plastic spacers and all that kind of stuff. Also, like I showed in the previous video. I still got a lot of mechanical hum going on with the bottom So I will now disconnect the two transformers and try and see if I can add the same kind of rubber mounting. But now there is a new challenge, and that is because we got two transformers, there could be a phasing kind of problem. So that is why I have marked all the different connections to the two transformers, as you can see here, so that I can restore the wires in exactly the same way, because these two got, of course, the same color. So what happens if I swap these and not those, or the primary side? You can imagine I will have a very, very big surprise coming up when I power this on for the first time. Whew, that was a lot of work, because we got two transformers, double the work. So let me just super fast show you guys what I've done. That will be my 3D printed spacers. Also 3D printed spacers or isolators here on the back. Screws also got heat shrink. Also the bottom screws got heat shrink at each end. And yeah, the usual little paper isolator that was down there. And I also put heat shrink on the screws on each end as well here. So that means I'm not having a short circuit at the bottom screws as well. I don't know if this is real easy to look at, but here, can you see it now? Yes. We got some thin pieces of rubber, and that is all the way around down here. So that means vibrations in the transformer is not going to transport itself that well to the metal chassis. Under this bracket here, I also added a little thin rubber isolator, right? And now we can try and turn it on again. Yes, of course, we still got protective earth on both of the metal here, because if there is a leak to your to the metal, definitely you want to know about it. But anyway, let's crank it on and let's hear how it works. Did you hear anything? No, you don't hear anything, and that is because there's nothing to hear. Isn't it amazing? It is that quiet. I don't hear anything. I don't feel anything. And the idle power is now dropped to 36 watts. So we had two short loops, one on the top and one on the bottom, that was using all that power. And now it is super silent. So I only got one thing left to do, and that is to test the thermal. How is it really working over here? And for that I need to load it a little bit. So now I'm testing it a little bit. Only about 200 watts output. And the input is 345. And this is quite normal because it is half linear, half switch mode, or pre-regulated kind of. So it's really not a super lossy linear power supply. But let's look a little bit on the thermal issues. So this is how it looks like. Look at the left and the right heatsink. This is the pre-regulator, and this is the linear regulator. This is the output. And of course you can see the heat sinks. And you can clearly see the heat sinks. They are not at all transferring any kind of heat to the outer aluminium frame. So that is what I'm saying. There is a thermal issue here with the design. So it will make the heat sinks, the internal heat sinks, much warmer than the outside aluminium frame. What you see here is the current sharing resistors in the sources. Those are field effect transistors, by the way. And as you see, they're sharing the current correctly. So all that is nice and fine. I will try and see if I can fix this issue, because there is a tiny little gap between this internal heatsink and the outer aluminium frame. And as you can see here, this is a lot bigger and higher and much nicer. And the air that goes in here is quite limited. So that is, of course, yeah, why it is not the most optimal thermal design. Oh, yeah, here you see the gap. But I got some liquid gap pad or gap filler that could definitely be used to solve this problem. The old heatsink compound was completely cracked and dry and didn't really have a good physical connection between the main plate here and the heatsink. So I applied some new, and in between this bottom plate we got about 1 millimeter of gap, and I can't change that gap because of the pins of all the transistors, and it would require quite a lot of rebuilding or bending the legs or kind of fixing that. But that could be the best way to do it. That means this can be screwed directly into the chassis. But I'm filling in some of this liquid gap pad. It looks a little bit like chewing gum, and it is heavy as metal. It's really funny because it's super conducting when it comes to temperatures. Well, you can see the temperature sensor of the main power heatsink here, and that is controlling the fan. So now I'm done with the 2 heat sinks, and as you can see here, I have added gap pad in between both of the heat sinks, and I'm doing exactly the same. I don't know if you can see what is going on here. The difference is we now have a much better thermal transfer, so the heatsink in here is not warming up, and because it's auto ranging due to the power resistors down there, you don't really see it that obvious. But if we go over here and it auto ranges now, you will see that the entire side is nice and warm. And then let's look at the pre-regulator side. I think it is obvious. We totally nailed it. All the thermal problems are now nice and fixed. See, the side is more or less as warm as the main heatsink inside. So I think it's very impressive how well this thermal goobity goop thermal pad paste is working. I mean, look at the temperature of the internal heatsink, and the outside heatsink is the same. It is 349 watts of input power, so it's the same test as before. So I think I will call it the end of the video, and I will repeat that all the technical details about this entire power supply is very well explained in the previous EA video, and I will link to that video in the description, and that is where you will find all the nice technical details. Thank you very much for watching. See you again soon. Bye bye.